Hi, I'm Bill Morrison. I design studios, control rooms, and big monitor systems for control rooms. I've been involved in acoustics for a long time. Technically, I'm an ex-physics professor, but I've really specialized in acoustics. And you can see some of our work on Bill Morrison Acoustics Instagram. We are involved in refurbishing old control room monitors and also manufacturing new control room monitors. We manufacture them under the BIGS trademark, like this. It used to be big monitors were called main speakers, or they're called mains, but now they're called BIGS, which is kind of a better description of what they are. In order to reproduce sound at the high sound pressure levels, you have to have some special components. And I have some in front of me on this this hydraulic table, which is necessary for handling big speakers. This is a wood horn that is a tad wood horn. It's used for mid-range and high-frequency output and typically used in two-way systems. This is a 15-inch driver that's used. This is a tad driver. And you can see the motor structure on it is quite large and powerful. It incorporates some well-damped cone materials so that resonances in the cone are well controlled. These are some of the high compression drivers that might be used in a big monitor system. This one is TAD 4002, and this larger one here is a TAD 4001. And these large motor structures and magnetic motors and these drivers are really necessary in order to achieve the efficiency and output capability that's really needed for big control room monitors. By way of comparison, this is the motor structure of a high-frequency driver out of a Genelec speaker, and by way of comparison, it's much smaller than the magnetic motors that are used in these compression drivers. It's really necessary to achieve the 15, 20, 25 dB output levels over what you can achieve with a near field monitor. So that's really some big differences between big control room monitors and small near field monitors. The typical big control room monitor back in the rock and roll era was a dual 15 with a 2-inch compression driver, and the Augsburger systems were quite popular and quite good. Systems that were originally set up by George Augsburger were very good. He's a good acoustician and knows what he's doing. A lot of times these systems went out as blueprints and specifications for their construction. Sometimes they weren't implemented as well as they could be. Sometimes substitutions were made. So it's basically there were some problems with them from consistency standpoint. Normally they would be set up with real-time third octave analyzers, and that wasn't really the most precise way to determine the correct equalization, crossover points for these systems. But if you do have an Augsburger system, there are some things you can do to really improve the monitoring accuracy if you think someone has tampered with it and it may need some correction. One of the best ways to improve that is to incorporate a subwoofer. And a subwoofer, if it's properly integrated into the system, will have a low-pass filter and a high-pass filter on it, so that the frequencies above, say, 50 or 80 or 100 all go to the main system, and the actual deep bass, which requires some high excursion cone capability, is allocated to the subwoofer. This cleans up the main system as far as distortion and lowers the distortion, especially intermodulation distortion, as well as harmonic distortion. But by not requiring the 15-inch drivers to handle the deep bass and as well as the mid-range area, the distortion is minimized. Normally, in this type of system, instead of like a 10-inch here, in this particular case, there would be the large type of horn with a 2-inch compression driver on it. Initially, the Augsburger systems used a fiberglass horn that Northwest made, and then later on they used their own wood horn, which was quite good. This horn would be located above or below the 15-inch drivers, and there would be, depending on the way the monitor was mounted in the room. So there were various components that were used. There were some leeway as to what drivers were used. You need to make sure that if there were any substitutions for drivers, that they're well-behaved drivers and really appropriate for accurate monitoring. One of the ways to make sure that they're appropriate is to actually test them, and so I recommend that on any used system, that you check the frequency response of them and check the teal small parameters, distortion measurements, and what have you, just to make sure the drivers are good. Another way to really improve them is to utilize some of the high-quality DSP crossovers that are available now, and that lets you time align the system properly and equalize the system properly. So in order to do that, you have to have an analysis system that really will allow you to look at the time domain performance of the system. You want to be able to set up the time arrivals accurately from the drivers, and you want to be able to see what the system itself is inherently doing as far as the first arrival from the system to the engineer's position. And you've got to make sure that the monitor system is accurate in first arrival. And the way you do that is, of course, to define a time window that excludes the reflections from the sidewalls or any other surface in the control room that might be contributing a problem to them. So once you get the system accurately set up for first arrival accuracy, then you can worry about the actual room acoustics and making sure the room acoustics are properly set up. So I would say, as far as improving a system or making sure that your existing big monitors are working properly, you need to make sure that the subwoofer is properly integrated into the system to minimize the amount of bass requirements that the main system is reproducing. And you need to make sure the crossover is set up properly. And you do that through good crossovers. I recommend the DSP systems. And by analyzing it with a FFT type analyzer. There are a couple of FFT analyzers that are inexpensive and really worth investing in. There's the REW system and the ARTA system, ARTA. Originally, there's an older system also called TEF, Time Energy Frequency, that was marketed by Techron, and it's now marketed by Goldline. That's a good system also. So you need to make sure the system is set up properly and properly crossed over. You need to make sure the components are good. Test those individually and make sure somebody hasn't substituted some drivers that are inappropriate. and there are a lot of drivers that are just, not good. They have resonances in the cone materials. They have resonances in the surround. They may have resonances in the spiders, voice coils, dust caps, even the mechanical frame. And once they have resonances in them that are of high Q, especially, there's really no way you can correct for those or compensate for those in a useful way. The other aspect to improve the monitoring accuracy of these old monitors is to make sure that your room acoustics are accurate. And the way you do that is to treat the reflective surfaces. Any surface in the room that could reflect some of that sound energy from the monitors back to the engineer's position, where it could perturb the first arrival from the monitor, it needs to be treated so that those reflections are, at least sound pressure level wise, are at least 20 dB down from the first arrival signal. Typically in a control room, you'll see that there's a acoustical cloud suspended above the engineer's position, which is designed to absorb the reflection off the ceiling. Or you may find that the ceiling has a slant actually built into the geometry of it, so that it diverts the energy back to the rear wall where it's absorbed or diffused. You'll find RPG diffusers on some back walls, as well as absorption. And you'll also probably find a couch back there which serves as an absorptive purpose. Same thing on the sidewalls. You need to make sure those are, that reflection off the sidewall is absorbed, or there's an angle on the sidewall such that it doesn't reflect back to the engineer's position. A really good article about acoustically treating a control room or a listening room was written by Tom Hidley. Tom Hidley is the highest paid designer of control rooms. He wrote an article maybe 20 years ago. The name of it was How to Make a Room Sing for $3,500. And I'm sure the price has gone up a little bit since then. But basically, it's a very affordable way to make sure your control room is treated properly for accurate monitoring. So if you have a control room that you think has some problems with it, or you're planning on constructing a new control room, I recommend you read that article. Also, I wrote an article for Mix Magazine on using geometry in the control room to achieve monitoring accuracy. So that's relevant also. So I recommend that. So anyway, if you can find a good old Augsburger system or something, or if you have an existing one, just make sure it's working properly and you'll have a good system. Another good system back then was the Westlake BBSM 15, which is similar to this system in that it had two 15s in it. It had a high-powered 10-inch mid-range, actually the same mid-range that's in here, and it had a 1-inch high-frequency driver up here. This particular one happens to be a 2-inch one, and I just put this in here because it's kind of an interesting look. It's a vintage horn that Westlake made that was from the record plant in New York City. But normally, Westlake in the BBSM 15 would have a smaller walnut horn up here with a 1-inch compression driver, a small horn about like this size. And that was also quite a good system that I would recommend for a big monitor if you're planning on finding a used one, and maybe you're lucky enough to already have one in your control room. And we also, I mentioned that you need to make sure these components are well behaved. If you find that you need to replace components in your big monitors, I'd recommend the TAD drivers. TAD was a division of Pioneer that was started to really engineer and manufacture the highest quality drivers in the industry, and they succeeded. So I'd recommend using those. They're a little bit difficult to find, but they are available on eBay and some of the other Reverb, some of the other forums that sell used equipment. You can also find them new in the box as well. But fortunately, a lot of these drivers were manufactured. Unfortunately, though, a lot of them were used in sound reinforcement systems because TAD marketed some products in that area. So you have to watch and make sure they have not been abused. I would recommend making sure they have the original diaphragms and cones in them, and that they've been, well treated if you're going to buy them. So check them out. Make sure the suspension feels nice and tight. Make sure the voice coil and everything is centered properly. Also test the teal small parameters of these. I recommend Dayton Audio's DAT system in order to check the teal small parameters. And if they deviate too far from the manufacturer's specs for those parameters, I would avoid those drivers. On the 2-inch compression drivers, the TADs used a beryllium diaphragm, which was very unique. They developed a very special process using vapor deposition to manufacture those or fabricate those. It resulted in a very low weight diaphragm that had very stiff structural characteristics. So it remained pistophonic up further into the high frequency range than what a normal diaphragm would be able to doing. So it had extended frequency response as well as excellent transient response. So you want to open those up to make sure those have the original beryllium diaphragms. You can tell because the original diaphragms had a perforated metal covering on them to protect the diaphragm, and the actual color of the diaphragm is a dark gray as opposed to like a shinier titanium or aluminum that some people may have substituted in those compression drivers. So I recommend making sure they have the original beryllium diaphragms. And you'll probably pay a little bit more for those, but they're definitely worth it, and they're really the best drivers that you can have for a system. There are other, usable diaphragms and usable drivers that will work, but by far the best is the TAD drivers. Of course, we manufacture some of our own systems under the trade name BIGS, and I have one here. This is a fairly narrow one so that it will fit into a smaller control room. It's a 1-inch compression driver, and the mid-range is handled by 10-inch drivers in a Diapolito configuration. One 10-inch above and one 10-inch below, and the same thing on the 15s. It's a Diapolito configuration with one below the mid-range and high frequency and one above. You probably can't see this in the frame, but it's up there. And then the Diapolito configuration does minimize the amount of reflection off the sidewall. So if your control room isn't quite perfect, you can still have some hope of achieving monitoring accuracy. This system is, of course, includes a subwoofer, so it's actually a 4-way system in total operation, and it's capable of very high output, low distortion monitoring. I have behind me a high output system, which is a Diapolito configuration for the dual 15s. So you have two 15s below the horn and two 15s above. The horn itself is a 2-inch compression driver, and this is actually fiberglass, not solid wood in this case, but fiberglass has been heavily dampened so that there are no structural resonances from the fiberglass material that kind of introduce its own signature to the acoustic output. This system is coupled to a subwoofer which has 3 of the dual voice coil push-pull JBL designed 18-inch drivers in it, and it's in a 4th order Butterworth cabinet tuned to 20 hertz, so it's capable of quite high outputs at low frequencies. And this system obviously will play very loud. You have to be able to play system very loud. If you want to listen to mulatto and Southern bitch, this would be the system to listen to it on. We also have probably 20 other designs for big room monitors, and if you need a monitor system or something, you're certainly welcome to come and take a look at some of the different designs that we have and see if those might be appropriate for your particular control room. So anyway, this is kind of like, episode 1 of this series on big control room monitors. And I'm planning on doing some more as far as explaining subwoofer performance and how to achieve excellent transient response in subwoofers. You really want to have your chest kicked in on some of those kick drums and what have you, and so transient response is very important. Also wanted to go into other aspects of control room accuracy, acoustics, studios, although studios are not really used that much as far as big live studio areas. A lot of times it's really just a vocal booth, and in some cases a live drum recording area, but the control room acoustics is very important, so we want to look into that. Also how to set up crossovers, that kind of thing. So once again, you can check out some of the work that we do on Bill Morrison Acoustics. The Instagram account is Bill Morrison Acoustics. And until the next episode, I'll see you then. Thanks.